Hello guys, so good night. Today I did I think it was this one or either that one or this one, and basically I kind of rewrote it, or it was more of having it a better solution like in my head, so which explained this instead of like just drawing and intersecting some sets. I also got wait, I can show this, I think. Yeah, so basically I got this part, so I wrote all this text so I could get here, which means I skipped this part, which means I got here, so I skipped this part. And yeah, this is the mathematical logic to translate all this text, I guess. I also did this one. By the way, I have to say that I have no idea if anything here is right or wrong. Before that, I tried to do this one, which someone gave me a hint, which is basically this thing. Hint: first consider D equal B union C, and try to do that but with n cases. Sorry. And yeah, I had done that exercise before. The problem I was having here is I don't know, just getting this thing right, I guess. And I'm going to retry it tomorrow, so yeah, hopefully tomorrow I will get it right, and I will try this using this because I heard it, but I didn't want to try this exercise again. After that I tried this one, show this, and what I did was so basically I tried to prove that we could have a summatory of another summatory. So the first summatory would have the number of elements in A, and the second summatory would have the number of elements in B. So when combining these two, there would be a number of number of elements of A times number of elements of B. After that, I tried to do this 22A and 22B. I don't know if this is like not correct, but like I still don't know if it's correct, but I meant if this is a well done proof, I guess. So I started by, well, doing some random example, like a set that only has 1 and 2. I see that it has the subset that is a set, the subset with one element, the other element, and the null set. And after that I realized that, well, what if we added another element here, like a 3, and then it would have like it would duplicate the amount of subsets, because these ones would stay, but we would also have another, we could also just insert the 3 in each of these subsets and also keep them. So we would have these sets and another set, which would basically multiply by 2. So that's where I realized these two elevated to n came from, and how I show here 2 times n times 2, 2 elevated to n times 2 equals 2 elevated to n plus 1. So I started n equals 0 would be 2 elevated to 0 equals 1, initial case, and whenever I add an element it would be times 2. So I got to this expression, 2 elevated to 0 times 2, but this times 2 has to be done n times. So we get 2 times elevated to 0 plus n, which equals to 2 elevated to n. So for the next exercise is how many subsets, how many subsets are there that have exactly m elements. Let me check. I don't want to make this too long. Okay, this is already 5 minutes. I'm going to speed this up a little bit. So I just did a random set that I thought about and tried to see how many elements for each m, how many elements there would be, and I realized it would be 1 1, 4 4 and 6. This looked similar to the Pascal's triangle line. So yeah, I just did n, which would total number, C, I think this is combinations. I'm not entirely sure, but I kind of know what this means. Like I just don't remember. And M would be the number that we are trying. Next, I read the mappings part, which it's basically what the function is, but given to specific sets. Like when we usually consider a function, we think of something that goes from R to R or R2 to R or something. Read the definitions, which basically told about subjective and injective and then bijective, which is the combination. And for the problem sets, I did exercise 3, which was basically proving the properties that were already told, but just like proving for specific sets. Yeah, I'm also not sure if this is completely right, but yeah, I think these ones are good. And yeah, basically sets things like unions and showing that mappings are equal, and then this specific exercise. Yeah, I think that's all. So yeah, thanks for watching and goodbye, guys.